Hello everyone, this is a short introduction to our Agrihub INSPIRE Hackathon Challenge number 9 called New Social Space for Geographic Information Sharing and Education. In this challenge, we wanted to introduce and spread the usage of Hub for Everybody portal that enables everyone to develop, publish and share their own maps, learn how to build map compositions, build own maps describing specific places or local problems. And all these tasks were supposed to lead to support effective reuse of existing data or build new data content, promote regions, or prepare new type of educational content. I think I can confirm that our tasks were successfully fulfilled. We were able to work on 3 specific use cases that will be later presented here, and that were focused specifically on the tasks mentioned earlier. But first, let me briefly tell you something about the background of the number 9 challenge. This challenge has been led by 3 mentors, Mr. Otakar Čerba, who was mainly responsible for one of the use cases, Mr. František Zadražil, who is the main developer of the technology, and then myself, Markéta Kolárová, responsible for smooth communication within the team and participants. As I already mentioned, our team has been working on 3 specific use cases closely linked to the ambition of the challenge. First, we decided to go and further develop the regional attractiveness challenge, where we have used the data collected in a certain region and thus developed and uploaded a new map into the Hub for Everybody portal. Second was the use of vegetation indices on Rostenice farm, whose results will be presented by Vincent with reused data from the past. And the last but not least ambition of the challenge, creating of an educational content, was covered by our practical workshop organized for the students of Charles University in Prague. All of this would not be possible to organize without the main portal Hub for Everybody, which was developed by František, who will also brief you about the technology that stays behind of this work. So, we were able to organize a couple of overall meetings and one large webinar dedicated to Hub for Everybody technology with an audience of registered 120 participants, geographically covering countries throughout the whole Europe, then Africa, South America, and also Asia. And as I already mentioned, we have organized a separate practical workshop for students of applied geoinformatics and cartography at the Charles University in Prague. In our team, besides of the core team around the Plan for All organization, there were 7 registered participants from Uganda, Nigeria, Burundi, India, Pakistan, Uzbekistan, and Slovakia. So those were the overall information about the challenge, and now let's move on to the specific parts and results of our challenge. Thank you.
Hello, my task here is to tell you some technical details about the Innovation Hub, which is a cornerstone for our challenge. My name is František Zadražil and I welcome you to this part of the presentation. From some points of view, the portal can be viewed as a common web portal which contains some blog section. You can open it here, which contains forums and articles. But our hubs are maps oriented, which means that the core of the portal lies in geodata and maps. And this functionality is hidden in the tools that are not visible to the user. We call this the geodata management workflow, and to say it in short, it is a set of tools integrated together into one complex solution, which is designed for anyone to be able to not only browse through existing maps, but most importantly to publish own map layers and maps and then share them with others. There are components for publishing data on the server. That service is called Layman here. There is a framework for web map applications, HS layers. There is a desktop tool in the form of QGIS layman plugin. And of course, if we are dealing with geodata, there must be a metadata catalog, which is called MITSCAF in our case. All those tools give the user a simple way to publish data, to create thematic maps, to make them available on a web map or through the QGIS desktop. And recently we have adopted a new component into our hub, and that is QField. QField is a native mobile app based on the same libraries as QGIS itself. It is designed to work with maps out in the field and to collect data. Close integration of QField into the hub is actually covered by another challenge, and that's challenge number 10. So if you are interested, please check this one too. And if we are talking about a web portal, I cannot forget to mention the content management system.
Hello, my name is Vincent.
Which
I represent you.
encompasses the components and create the actual content that is visible to the user. The content management system is based on the Wagtail CMS, and we have extended the default functionalities with the ones that are needed for working with geodata. So there is, for example, a map widget which allows you to insert a full-featured HS layers map into any web page you are creating using the standard content management tools. So you can create a page, you can insert some HTML to the page, you can insert some text formatted, you can insert images, and in the very same manner you can insert interactive maps. So this whole package of tools lets you quickly create maps and nice web presentations including those maps. You can present your research result this way, your students' works, or just your private data that you want to share with someone else. You can create story maps or whatever allows your imagination here. Okay, that is all from my side in the context of the technical solution of the web portal. Thank you for your attention.
Hello everybody, I would like to introduce the territorial attractiveness maps which our group is publishing and sharing through the hub for everybody. What is territorial attractiveness? It is an assessment of regional potential. You can see three levels of the territorial attractiveness: the national level, regional level, and the local level, which is the actual topic of our group. The main difference between national or regional level and the local level is the input data, because for the national level attractiveness we are processing usually the statistical data, but we do not have such type of data for the cities or municipalities. Therefore, we have to use three other types of data. First, points of interest. The second, land use land cover data. And third, some local data such as surveys or data collected by municipalities. On the local level, we cannot work with the administrative borders. Therefore, we use regular grid, 100-meter hexagons. As I mentioned, we publish this data on the hub. In this slide, you can see two approaches for attractiveness assessment of the Klatovy city, and we use slider to enable to see both types of attractiveness. If you want to know more about the local attractiveness and visualization of local attractiveness data in the hub of everybody, you can visit the blog of Hub for Everybody, and there is a short blog post about local attractiveness with some map examples. Thank you very much.
The Spectral Indices page made on Hub for Everybody with Wagtail and QGIS. So this page lists several spectral indices used to monitor agriculture. Let's begin with the normalized difference tillage index. First, we have the definition of it. It quantifies the agricultural preparation of soil by measuring the difference between two shortwave infrared satellite bands. How do you calculate it? You have the general formula here, and the bands are according to Sentinel-2 satellites. We have the link of the reference. It's easy to add it with Wagtail. And an example of NDTI on Rostenice farm, July 1st, 2020. So we can easily which parcel have more soil preparation. Let's go to another index, the normalized difference vegetation index. So it quantifies vegetation by measuring the difference between near infrared, which vegetation strongly reflects, and red light, which vegetation absorbs. For example, when you have negative values, it's likely that it's water. On the other hand, if you have an NDVI value close to +1, there's a high possibility that it's 10 green leaves. There's a general formula here. Once again, the references. And an example on Rostenice farm of application. Here, so you can see you have greener parcels than others, so different density of vegetation. Let's go to another index, the enhanced vegetation index, EVI. EVI is for crop with higher canopy density, and EVI tends to saturate. EVI is more important to use for this type of crops or growing stages. It's like an advanced version of the NDVI. How do you calculate it? You have the general formula here, once again, references. And on the map, I will show you something you can do. You can see here my layers. I have the Rostenice borders of the parcel. I have a layer for May and a layer for April. So we are viewing the layer for April. You can here put the language into English. You can here enable the swipe. And the swipe allows you to compare two layers. So we have the May layer on the right and the April layer on the left. We can see it's getting greener on May. So it's really useful to take decisions. It can help to take decisions to monitor agriculture. Let's go to another index, the radar vegetation index. Every eye can be used to monitor the level of vegetation growth. The SAR can penetrate the clouds, thus it has the potential to monitor the crop growth in all the seasons. It ranges between 0 and 1, and it is sensitive to the biomass. How do you calculate every eye for S1? So the general formula for every eye is here, and you have to know that for every eye for Sentinel-1, the calculation we call a custom script you can find on the reference if you want to know more about this. So we have a layer for April, a layer for May. If I zoom on the farm, the location is not set on the map already, but it can be fixed. And so once again, we can enable the swiper. If I put April on the left, May on the right, I can compare easily the two layers for this with this index. And we can see we have more greener parcels on May, so we can say that vegetation growth, we have some change in the vegetation growth. So this is the end of the presentation. I hope you enjoy it and have a nice day.